Have you ever stopped to think about all the paradoxes that reveal absurd and incomprehensible facts that defy the logic we know? Throughout our evolution from the Stone Age to the contemporary world, we've deciphered great mysteries, yet others remain unexplained, showing us how absurd we are and how little we know about the universe. In the following minutes, you're going to learn about the 10 most fascinating paradoxes of the universe that will make you question everything. We'll start with the easier paradoxes and progress to the most strange and realistic ones. You'll see that there comes a point when your mind won't be able to unravel the mystery. Remember to leave a like and subscribe to the channel if you enjoy the video. Your subscription helps us a lot. Let's start. Paradox number 1. The night sky is black. Olber's paradox presents a puzzling contradiction. The night sky is black, but if the universe were infinite, it shouldn't be this way. If the universe had no end, every part of the sky would be occupied by a star, making the sky completely bright, filled with light. Yet, what we see is a mostly dark sky sprinkled with a few thousand stars, with vast empty spaces between them. This paradox was proposed by German astronomer Heinrich Olbers in 1823, who argued that in a static and infinite universe, dark regions shouldn't exist. The solution to this paradox is based on the theory of relativity and the Big Bang. The universe isn't infinite and is in constant expansion, so the light from all the stars hasn't had time to reach us. If the universe were infinite, hydrogen combustion in stars would have completed. But the fact that hydrogen still exists suggests that we live in a finite space-time. Paradox number 2. Only 5% of the universe is visible matter, composed of protons, neutrons, and electrons, represents only 5% of what we can observe and understand of the universe. Whereas the other 95%, this vast percentage remains hidden, invisible, and we call it dark matter. Dark matter, which constitutes 27% of the universe, holds galaxies together and forms large cosmic webs, influencing the cosmic microwave background. It doesn't interact with electromagnetic waves and is therefore transparent to us, but its effects on the universe are undeniable. Furthermore, the remaining 68% of the universe is made up of dark energy, which plays a fundamental role in the accelerated expansion of the cosmos. The most fascinating thing is that of that 5% of visible matter, we can only see about 1% due to our sensory and technological limitations. This raises a disturbing question. How have humans managed to survive with only 1% of the received information? It's as if a fish believed its entire universe was a pond, or that everything is based on black and white. Our information is limited and fragmented, but it all suggests that there's much more to discover. These gaps in our knowledge confront us with incomprehensible events and paradoxes that we can't explain. Paradox number 3. How many dimensions are there? Our world is based on 3 dimensions: width, length, and height, with an additional dimension that we can't control, time. Albert Einstein postulated that to define a 3-dimensional object, we also need to locate it in space at a specific time. However, with the development of string theory, some scientists have proposed that to solve many problems in quantum physics, we need to consider more dimensions. Depending on the calculations, there could be 11 dimensions, or even up to 26 dimensions. This challenges logic and common sense. If it's already hard to imagine beings with 4 or 5 dimensions, how could we conceive 26? Knowing these additional dimensions, which for now exist only in mathematical calculations, could allow us to unify the 4 fundamental forces of nature: strong nuclear force, weak nuclear force, electromagnetism, and gravity. All points to the possible existence of more forces, such as a hypothetical particle called the dark photon, linked to dark matter. This 5th fundamental force of the universe would be a further step in understanding our reality. However, as 3-dimensional beings, we're limited in our ability to perceive and access these additional dimensions. Like a fish trapped in a pond, we can understand them theoretically, but cannot interact with them. Paradox number 4. Fermi's paradox in intelligent life. One of the great mysteries of the universe is Fermi's paradox. Enrico Fermi was the first to raise the question in 1950. If there are so many stars and planets in the universe, why haven't we found evidence of intelligent life? According to Fermi, intelligent life is curious by nature and tends to expand. Therefore, an advanced civilization should have spread throughout the galaxy within a few million years, and we should have evidence of its existence. But we don't. There are no radio signals or signs of galactic civilizations. This great silence intrigues us. Where is everyone? Many proposals aim to solve this paradox. Michael Hart suggests that maybe there's simply no one else. Other scientists think civilizations might not be sustainable long-term and, therefore, become extinct before they can expand throughout the galaxy. Computer simulations have suggested that the galaxy could have been teeming with life at certain times, followed by intermittent periods of near emptiness. Perhaps we're in one of those empty periods, or we're one of the first civilizations to emerge. Time and great distance are key factors in this equation. It's possible that the solar system was colonized in the past, but hasn't been visited in millions of years. Paradox number 5. Motion doesn't exist. The dichotomy paradox of Zeno of Elea is one of the oldest and most fascinating mathematical paradoxes. This Greek philosopher, born in 490 BCE, wondered if motion really exists. Suppose we want to travel a path. Before reaching the destination, we must cross half the distance. Then, to cross that half, we must cross its own half, and so on. If math tells us there's an infinite number of possible divisions, how can we reach the destination? Mathematically speaking, the journey should never begin, as there's always a half to cross before reaching it. Yet in reality, we do reach our destination, making this paradox even more mysterious. Some have tried to resolve it by accepting that the sum of infinite halves equals 1, but this doesn't explain how we reach the destination. This paradox makes us question whether time and space can be divided infinitely or if everything we perceive is an illusion. Paradox number 6. Schrödinger's cat. This thought experiment, proposed by Erwin Schrödinger, challenges our understanding of quantum reality. Imagine an opaque box containing a cat along with a vial of poison and a radioactive particle. The particle has a 50% chance of decaying. If it does, the poison is released and the cat dies. If it doesn't, the cat remains alive. According to the Copenhagen interpretation, the quantum particle remains in superposition, that is, in both states, until someone observes it. This means the cat is both alive and dead until we open the box and observe the outcome. This concept defies our intuition and logic. Where does the cat go if no one observes the experiment? This paradox has inspired many theories, including the idea that the universe branches into different realities depending on the observed outcome. In one universe, the cat is alive. In another, it's dead. But the question remains, what is reality? Paradox number 7. What is time? Time is a physical magnitude difficult to understand. Although we experience it as a sequence of moments, according to relativity, time isn't absolute. It's influenced by gravity and speed, meaning each object in the universe has its own time. Time seems to advance in only one direction, toward the future, with no possibility of going back. Yet physics equations tell us nothing about the present or any particular moment. It's as if everything happens simultaneously, and our perception of time is just an illusion. Imagine you're watching this video right now, but your current self no longer occupies the same space-time as a second ago. According to physics, that self still exists in another plane, though you can't see it. This means time is a succession of snapshots, and all people and moments from the past still exist, separated only by time. Moreover, entropy, which indicates the degree of disorder, tells us that everything tends toward chaos. If the universe began with absolute order, how is it that we now perceive it in a state of greater disorder? Entropy tells us that disorder always increases with time, but this leads to another paradox. Why was there more order in the past? This arrow of time causes time to advance in a single direction, but it's unclear why. Some scientists propose that there could be more than one universe, and in others, the arrow of time could point in different directions. That is, the past of our universe could be the future of another. But what is time really? Is it another dimension like space, or something completely different that we still don't understand? This paradox leaves us with more questions than answers, showing us how limited our understanding of the universe truly is. Paradox number 8. The universe expands into nowhere. This paradox challenges our understanding of space and the expansion of the universe. We know the universe is expanding, but where to? According to the Big Bang Theory, the entire universe began as an infinitely small, dense point that exploded, and since then, space itself has been expanding. This doesn't mean that the universe is expanding into something. Rather, space itself is being created as it expands. Imagine a balloon inflating. As it fills with air, the surface of the balloon expands, but not in the conventional outward way we envision. The space of the universe isn't filling a pre-existing space. Instead, it's creating new space as it expands. But this challenges our logic. How can there be an outside of the universe if the universe encompasses everything? This is difficult for our three-dimensional minds to understand. According to relativity, space and time are intertwined in the fabric of space-time, and as the universe expands, both time and space expand along with it. So, the universe has no borders or center. It's everything and has no outside. Paradox number 9. The bootstrap paradox. The bootstrap paradox is a perplexing scenario in time travel and causality, raising questions about the origins of certain objects or information. Imagine you travel back in time and hand William Shakespeare a copy of his completed works. Inspired, he transcribes them and publishes them as his own, which leads to the question, who actually wrote Shakespeare's works? In this paradox, an object or information seems to exist without an origin. It's passed back and forth in a closed loop. This paradox defies our understanding of cause and effect, creating a loop where the cause of an event is also the effect. The same issue arises with technology or knowledge that's taken back in time. The question remains, if it has no true beginning, how did it come into existence? Some interpretations suggest that this paradox could imply alternate timelines, or that causality itself is more complex than we currently understand. In any case, the bootstrap paradox challenges our perception of time, suggesting that it might be much stranger than we think. Paradox number 10. The observer effect in quantum mechanics. The observer effect suggests that merely observing a phenomenon can alter its outcome. This paradox is especially evident in experiments like the double-slit experiment. When electrons or photons are fired through two slits, they create an interference pattern, as if they behave like waves. However, if a detector observes which slit each particle passes through, the interference pattern disappears, and the particles behave like individual particles instead of waves. This change in behavior implies that the act of observation affects the particles, but it's not clear why. This paradox challenges our understanding of reality, as it suggests that particles might not have a defined state until they are observed. In essence, it seems that the observer's consciousness plays a role in shaping reality. This mysterious interaction between consciousness and matter has led to various interpretations, including the idea that reality might be a kind of simulation or that consciousness is integral to the fabric of the universe itself. Whatever the case, the observer effect remains one of the most fascinating and unexplained phenomena in physics. These paradoxes illustrate how much we still have to learn and how limited our current understanding of the universe truly is. Each paradox challenges us to think beyond our everyday experiences, revealing the complex and often baffling nature of reality. They remind us that the universe is not only stranger than we imagine, but, as some might say, stranger than we can imagine. And, ultimately, these paradoxes might hold the keys to deeper truths about our existence. Thank you for exploring these mind-bending concepts with us. If you enjoyed this journey through the universe's greatest mysteries, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, stay curious and keep questioning everything around you.